Welcome to The Maintenance Mindset, an audio-video podcast brought to you by the Multifamily Media Network. I'm your host, Paul Rhodes, and over the more than 3 decades in the apartment industry, I've had roles that include being on-site, providing services as a vendor, creating and delivering multiple education programs, and active association work. This podcast is centered on the often overlooked role that our on-site maintenance workers play. You know, the men and women that respond in the middle of the night to the toilet call, or the after hours, it's really hot in my apartment request, or my favorite, my ring fell down the drain, get over here now. In other words, the often unsung heroes who are responsible for asset preservation and resident satisfaction. Working in multifamily maintenance provides interesting, sometimes amusing, and often fascinating stories and viewpoints. My encouragement to you is this: whatever you do it with a maintenance mindset. Hey there, welcome back to the Maintenance Mindset. This episode, we're going to continue a discussion that we started last episode on water heaters. And if you have yet to hear that one, do yourself a favor, hit the pause or stop button, depending on your app or where you're viewing this, and go back and listen to that one, because we're going to pick up right where we left off. We're discussing what's inside the tank on both electric and gas water heaters. We started with the dip tube and the need for preventive maintenance. We're going to continue on the inside of that tank because the other long object that is inside that tank is called an anode rod. And the anode rod is the single most important item inside your water heater tank that determines the overall longevity of that tank. A lot of technicians believe that the anode rod is there to be a part of mineral management, and that is not correct. The anode rod is inside of the water heater in contact and attached to the shell. It's because of what a water heater is made out of and the substance it's holding. Now, our first episode, we talked a little bit about the science. Well, in addition to the calcium and the scale that happens inside of our tank, we have another something that's going on, and similar again, it affects or has some commonality with maintaining a swimming pool, and that is pH. Now, water as a substance has a value. Matter of fact, everything has a pH value. pH is a scale that goes from 0 to 14. 7 is a neutral pH. Anything below 7 is considered acidic, and anything above 7 is considered alkali or base. The reason that this is important for a water heater is because of a battery. You know, those things that we use inside our remote controls and our tools and what we do, what we use and need energy for to be portable. I mean, it's very similar to what we have inside of our cell phones as well. Now, this is a battery. A battery works by taking a commonly acidic, but it could also be alkali substance, and breaking down dissimilar metals so that those dissimilar metals throw off electrons. In other words, the electricity that we use to power our devices comes from the deterioration of metals. Over time, in a non-rechargeable battery, the battery wears out. All the electrons that can be produced above a certain level that we need to power up whatever our device is, it just stops working. Other batteries you can recharge by re-adding electrons back into those substances. And if you're expecting this to be a Mr. Wizard episode, it's not. I'm nerdy, but I'm not a scientist. The reason why this is important is think about your water heater. The tank is made out of steel. It's welded together with a different kind of steel. You have fittings that are welded on that also have a different kind of steel, and there's aluminum fittings as well. So in other words, we have dissimilar metals that are in contact with a substance that has pH. In addition to this thing providing hot water, it also provides electricity. Now, we're talking millivolts. I mean, a very, very small quantity, but even that small quantity can do damage. That small quantity of electricity will be cast off. And if we don't give that electricity a job, it will find one. Electricity moves through the path of least resistance to a load to do a job. That's one of the things that electricity does. And we harness that all day, every day in our devices and appliances and the lights and the camera I'm using in the computer and all of the things that we take for granted. But that electricity functions the same way inside our water heater. And that means we've got to give that electricity a job or it's going to find one. If it finds its own job, it will eat through the tank. It could damage your pipes, your plumbing, your fixtures, and cause other issues. So we give it a job. That job is an anode. An anode is a device that is a softer metal. It is easier for the electrons to break down. So we want the anode rod to deteriorate over time. If the anode rod does not deteriorate over time, then our tank will deteriorate over time and fail quickly. The anode rod itself is a rod that is made out of either magnesium or aluminum that is attached on the top of the tank by a six-sided socket. Now, if you look at the top of a water heater, you will see a plastic plug that covers up a hole that's in the outer metal shield. Underneath that plastic plug, or if you don't have a plastic plug, there will be some insulation that's there. Underneath that is that six-sided socket. Attached to that socket is just a metal rod. Again, it's made of either magnesium or aluminum, and you have differences because of water quality differences across the country. Those two substances, aluminum and magnesium. Magnesium is used, one, because it's cheaper. It is less expensive to manufacture than aluminum. But the reason why we have the option for aluminum is that depending on what your water source is and all of the minerals and the chemistry that's involved in that dihydrogen monoxide, it can have an adverse reaction with the anode rod and produce a smell. The smell will be sulfur. According to water heater manufacturers, if this is occurring at your property, one of the solutions is swap out the anode rod, or when you replace the water heater, replace it with a water heater that contains a different anode rod. The less expensive, again, is magnesium. If you have a problem of that sulfur-like odor coming out of your hot water faucets when you turn them on, change the anode rod from magnesium to aluminum, or if it's aluminum, change it to magnesium, and the smell might go away. This anode rod's job is to deteriorate over the lifespan of the water heater. In other words, at some point in time in your water heater's life, the anode rod will disappear. Over time, it will get smaller and smaller. It starts out being roughly an inch and a quarter in diameter. And as far as length, it goes from the top of the tank until roughly a foot or 6 inches off the bottom of the tank. This is a critical piece that must be in place. As a matter of fact, I've read and through some research, we can extend the life of water heaters just by, one, performing preventive maintenance, flushing them on a regular basis, and two, changing out the anode rod whenever it needs it. How do you know when an anode rod needs replacement? Well, one of the big indicators is when the anode rod goes away, you will have that sulfur smell appear that wasn't there before. But just because you don't have a sulfur smell, the anode rod might be deteriorated or almost completely gone. This is where that next piece that is found inside the water heater tank, and that is this one. For those of you watching on video, I'm holding up a temperature and pressure relief valve. This valve has threads and a temperature sensor that goes inside the tank. Different models will have different requirements. Some of them will have a longer shaft and longer threads. Others will be shorter like this one. The end result is this is required on every single water heater. The reasoning, as you heat up water, the water expands. That means that you could have water being delivered at roughly 45 PSI, and yet water on the hot side of your system can be upwards of 60 to 65 PSI, pounds per square inch. How this happens goes back to the density changes that occur when you heat up water. Matter of fact, you heat up all substances. If you want to know more about this, check out refrigeration, because pressure and temperature changes. That's how your air conditioning system works. This particular device, you'll notice when we were talking about how to flush a water heater or how to drain a water heater, I did not open the top of the TNP valve. Now, the temperature and pressure valve, it does have a handle on the top. It's a little metal lever that in order to open it, all you do is you lift it up. By lifting it up, when we look on the inside of our TNP valve, what we end up seeing is there's a spring with a seal at the bottom of it. That seal or gasket is held onto a round, smooth surface, and the spring is the actual relief portion of the valve. This device should be left alone with one exception. The one exception, the time that we need to use this, is when we test it. According to water heater manufacturers, it should be tested a minimum of 1 time per year. And the way that you test a TNP valve is to open it and let it close back by itself. Meaning, you take the lever, you pull the lever up, and then you let it pop back into place. When it pops back into place, the gasket or the seal on the inside should completely seal back. If it does not, you replace the water heater TNP valve. It is not acceptable to push on the end on the lever to make it seal. That means you have put back into place a faulty piece of safety equipment. Yes, this device is considered to be a life safety equipment. And if you want to know why I'm referring to it as a life safety device, I would like for you to head over to the YouTubes and pull up a show called Mythbusters. This was a show that was on Discovery Network that is still one of my favoriteest TV shows of all times. They did 3 or 4 episodes where they tested water heaters. And one of those episodes, actually, I think it was a couple of the episodes, they hooked them up, they removed the safety device, and they intentionally overheated a water heater. The results were catastrophic. There's the one to me that is the most telling was the episode where they took a water heater, put it in like a manufactured basement, hooked it up, turned the water heater on, and then got behind blast shields, because when the water heater exploded, it went up through the floor, through the carpet, through the ceiling, through the roof, and continued on for roughly 50 feet into the air. When they did it in the middle of a parking lot, it shot the water heater like a rocket up over 250 feet straight up. We have these devices inside every one of our apartments if you have a tanked water heater. The device that is to be installed in that water heater to prevent that quantity of explosive force is the temperature and pressure relief valve. Now, that temperature and pressure relief valve, we need to leave it alone, except when it needs to be tested. This is why when I drain a water heater, I go to the bathtub. In addition, I go to the bathtub because we don't have an aerator there to get clogged by the debris or the calcium and the minerals and the stuff that are going to be stirred up by draining and refilling the water heater. Now, the dip tube, the anode rod, and the temperature pressure relief valve can be replaced without completely draining your water heater. All you need to do is turn off the supply valve, drain some out, attach a garden hose to the drain valve, and remove some water and allow air to go into the tank. What that will do is free up space at the top of the tank, and that's all you need. You do not have to completely drain the tank to replace either the anode rod or the T&P valve. For that matter, you can even replace the dip tube if required. All that you do is you unthread this and put a new one on. And remember, the need to replace a T&P valve is done by testing it. The way you test the T&P valve is you open it and let it pop back. This should be done a minimum of 1 time a year. At the end, the rest of it, the water heater functions by raising the temperature of the water. In the case of a gas, that means the cold water goes down through the dip tube, hits the burner at the bottom of the tank. In the case of an electric, the water heater goes down the dip tube to the bottom of the tank, and then as the water inside the tank begins to heat up using convection, the water, the colder water, will begin to rise up in the tank, passing by the burner, the 2 elements that sit in on the side of the tank. That way, again, the cold water goes to the bottom of the tank and the hot water leaves the top of the tank. That way, we only get the highest temperature water that goes out, which is what we use for our showers, to in our dishwasher and our washing machine. We're going to stop right here. And the next time we talk about water heaters, we'll discuss the differences between electric and gas water heaters and the service that they require in much greater depth. Thank you for spending your time with me today. I hope you have a fantastic rest of your week, and I'll see you somewhere. Thank you for listening to this episode of The Maintenance Mindset. I hope you take away ideas that apply to your current and future career goals. Please check out Maintenance Mindset Minute to hear short-form, high-impact, applicable, maintenance-centered information. Whatever you do today, do it with a maintenance mindset. If you enjoyed this episode, please like, comment, and subscribe. Visit multifamilymedianetwork.com to learn more about our other industry podcasts, thought pieces, and sponsorship opportunities. I'll see you somewhere.